Can a robot's nose actually be better than a human's? We're about to find out, and the answer might just blow your mind. Let's start with us. Our sense of smell is an incredible biological marvel. Deep inside our nasal cavity, we have millions of specialized olfactory receptor neurons. When you take a sniff of your morning coffee, odor molecules travel up your nose and bind to these receptors. It's like a complex lock and key system. Each receptor is tuned to specific molecular features, and when they're activated, they send a flurry of signals straight to the olfactory bulb in our brain. This is where the magic happens. The brain processes this complex pattern of signals, cross-references it with our memories, and instantly tells us, that's freshly brewed coffee. It's a system so sophisticated, it allows us to distinguish between thousands, maybe even trillions, of different scents. From the sweet fragrance of a rose to the warning sign of spoiled milk, our nose is a powerful survival tool. But what if we could build a machine that does the same thing, only better? Enter the world of artificial olfaction, or as we like to call it, the electronic nose. This isn't just science fiction anymore. It's a rapidly advancing technology that's set to change our world. So, how does it work? An electronic nose doesn't look like a human nose. Instead, it's typically a device packed with an array of chemical sensors. Think of these sensors as the artificial equivalent of our olfactory receptors. Each sensor in the array is coated with a different material that reacts to specific chemical compounds in the air. When air is drawn into the device, any volatile organic compounds, or VOCs, present in that air interact with these sensors. This interaction causes a change in the sensor's physical properties, like its electrical resistance. For example, the V-Volts from a ripe strawberry will create a different pattern of electrical changes across the sensor array than the VCs from a lemon. This collection of changes from all the sensors creates a unique digital smell print, or a chemical signature for whatever is being sniffed. But here's where it gets really clever. This raw data, this smell print, is then fed into a machine learning algorithm. This is the eNose's brain. Initially, the AI needs to be trained. You expose it to known samples, say, hundreds of examples of fresh salmon and hundreds of examples of spoiled salmon. The algorithm learns to associate the specific digital smell print of each sample with its label, fresh or spoiled. Through this training process, it builds a powerful pattern recognition model. After enough training, the electronic nose can identify new unknown samples with incredible accuracy, often in just a matter of seconds. It's essentially mimicking our brain's ability to learn and recognize scents, but with the precision and speed of a computer. Now, let's talk about why this is such a game changer. The applications are practically limitless and span across so many critical industries. Take safety and security, for instance. We've relied on sniffer dogs for decades to detect explosives, illegal drugs, and other hidden substances at airports and border crossings. While these dogs are amazing, they get tired, they can be distracted, and their training is long and expensive. An electronic nose, on the other hand, can work 24/7 without fatigue. It can be programmed to detect a vast library of chemical threats with extreme sensitivity and deliver results almost instantly. Imagine security checkpoints where the air is constantly being sampled, identifying potential threats with a level of consistency and speed that's simply not humanly possible. This could revolutionize how we approach public safety. Then there's the medical field, and this is where it gets truly incredible. Many diseases, including certain types of cancer and infections, cause subtle changes in our body's chemistry. These changes can lead to the release of specific VOCs in our breath, sweat, or urine. For years, scientists have theorized about sniffing out disease. Well, electronic noses are turning that theory into reality. Clinical trials are underway using these devices to analyze breast samples. They've shown promising results in detecting lung cancer, Parkinson's disease, and even infectious diseases like tuberculosis, long before traditional diagnostic methods might pick them up. This could lead to a future of non-invasive, inexpensive, and early-stage disease screening. A simple breath test could one day save your life. The food industry is another area ripe for disruption. Ensuring food quality and safety is a massive logistical challenge. How do you know if that shipment of fish is truly fresh? How can you detect contamination in a batch of milk before it reaches the shelves? Right now, this often relies on human inspectors and lab testing, which can be slow and subjective. An electronic nose can be integrated directly into the production line. It can sniff food products to determine ripeness, detect spoilage, identify contaminants, or even verify the authenticity of premium products like olive oil or wine. This leads to less waste, safer food for consumers, and better quality control for producers. It's a win-win-win. So the big question remains, robot versus human. Who wins the smelling bee? Well, our human nose is exquisitely sensitive and deeply connected to our emotions and memories. The smell of baking bread can transport us back to our childhood kitchen in a way a machine never could. We are masters of nuance and context. However, when it comes to specific, measurable tasks, the electronic nose has some serious advantages. First, consistency. A machine doesn't have a bad day. It doesn't get a cold that dulls its senses. Its performance is stable and repeatable, which is crucial for scientific and industrial applications. Second, it doesn't suffer from fatigue. A human sense of smell can become desensitized after prolonged exposure to a strong odor. An e-nose can keep sniffing and analyzing for hours on end without a drop in performance. Third, it can be designed to detect chemicals that are odorless to humans or even toxic. It can operate in environments that would be dangerous for a person. Finally, the data it produces is objective and digital, making it easy to store, share, and analyze over time. So, while we humans might win in the poetry of scent, the robot nose is poised to become an unbeatable tool for a huge range of practical, data-driven tasks. It's not about replacing our own sense of smell, but about augmenting our abilities in ways we never thought possible. We're standing at the beginning of a new sensory revolution. As these electronic noses become smaller, cheaper, and smarter, they will integrate into our daily lives. Your future smartphone might be able to smell the air quality in your home. Your refrigerator could tell you exactly which food is about to go bad. This technology promises a future that is safer, healthier, and more efficient. So, the next time you see a machine that looks like it's sniffing the air, don't be so quick to dismiss it. You might be looking at the future. Would you trust a robot nose to keep you safe or check your food? Let me know your thoughts in the comments below. Thanks for watching. If you're as fascinated by this glimpse into the future as I am, make sure to hit that subscribe button and ring the bell for more deep dives into the tech that's shaping our world. See you in the next one.